So looking at these two tables, we're going to try to decide if either of these are linear or if either of these are exponential, and then to try to find the equation of those functions. So looking at the first one over here on the left, I'm noticing that as I go up in consecutive x values from 0 to 1 to 2, that's a difference of 1 each time, 1 to 2, 2 to 3, I'm going up by 1. And my y value is going up by 2, so I'm adding 2 every time. Well, that should be a good hint right away that that's going to be a linear equation. In fact, because my slope is constant for every, in this case, 2 values that I go up, or for every 1 value I go to the right, I'm going 2 up. For every 1 value to the right, I'm going 2 up. And so with that, I can be certain that this one's going to be linear. And to remind you that in this case here, we know that it's going up 2 over 1. That is going to be my slope. I can think of it like this. If I'm trying to find the slope, 5 minus 3 is 2, 1 minus 0 is 1, and that's a rise of 2 over a run of 1, giving me a slope of 2. So I have my equation y equals mx plus b is the slope-intercept form of a linear equation. My slope I know is 2. So I can put that in for b, and the only thing left I need to find is the y-intercept. In this case, I've already given the y-intercept. The y-intercept is going to be 3, but even if I didn't know that point, I could plug in any other point in here. Let's say x is 2, y is 7, so y is 7, x is 2, and I can solve for b. I have 7 equals to 4 plus b, subtract 4 from both sides, and I find b. All right, so my equation is, oh, I ran out of room in the screen here. My equation is y is equal to 2x plus 3. Okay, now let's go ahead and try the same thing here. We're going to be adding 1. These are consecutive values of x. We're adding 1 each time. On this case, I'm adding 4, and then I'm going to add 12. Oh, right away I know this is not linear. This is not going to be a constant slope. For the same moving 1 on the right, I'm going to get 2 different values for the rise, so that one's not going to work. But what I do notice on this one, it's going from 2 to 6. That is actually being multiplied by 3. 6 times 3 again is 18. 18 times 3 is 54. So this time I know I'm actually going to be multiplying by 3 for each one of these. It's a little bit different here. And in fact, for my equation, and when we know it is being multiplied by the same thing each time, it is going to be exponential. The equation of an exponential function, we have y equals a times b to the x. A is the beginning value that I have at time 0. B is my growth factor. And actually, I found the growth factor over here as times 3. Just in case that you have a hard time seeing what that is, you can always take any value, any y value, and divide by its previous one to find that growth factor. 55 divided by 18 is 3. 18 divided by 6 is 3. 6 divided by 2 is 3. So I know that I have some value that I'm going to start with times 3 to the x. The growth factor is what the b is. Oftentimes, if it was a percent, like an increase of 10%, we would get 1.1, 1 and 1/10. Would be my growth factor here, but we can find that number simply by taking any term and dividing it by its previous y term there. Okay, so now how do I find a? Once again, I look here, I can see what my beginning value at time 0 is. I'm starting off with 2, so a is going to equal 2. But even if I didn't know that, let's suppose I had only some terms that were pretty far down on the list here. I knew my growth factor was 3. Well, if I know that my x value is 3, I'm basically going to be taking this number and I'm going to be dividing it by the growth factor, in this case 3 times. Okay, so I take 54 divided by 3, divided by 3, and divided by 3 times to get back to whatever the original one is. But if you're given the y-intercept here, that is our beginning value. We can start off with that as y equals 2 times 3 to the x.